Hey guys, welcome back to another video. So I've been doing a couple copper thermite mixes, and I've had some people ask me what's the best way to make the copper oxide. And there are quite a few ways to do it. However, I find that the best way, and by best I mean it produces the finest quality, purest copper oxide with no impurities in it, or at least little to no impurities. I would say it is 99.995% pure, is by doing it electrolytically. And so we just use copper wire like this. I've got some already bare right here. I have devised a pretty efficient method of stripping copper wire that I am about to show you here in a second, in case you don't have any bare. So without further ado, let's go ahead and let's get on to that. So see here, I have a nice long piece. This is about a 18-inch piece of copper wire. This is 12 gauge. The thicker the wire, the better. And so the first trick to this is, as you see, I have it pretty much straightened out, as straight as I possibly can get it. That makes it definitely easier. So then I take vice grips, clamp the one end of it, and then I just take a razor knife and kind of get the angle like this. And it doesn't want to always start. And then what you do is you hold the knife steady and you just pull the vice grips back along it. And of course this doesn't want to cooperate with me while I'm trying to shoot a video on it. There we go. You see there how it's just peeling right off. Okay, there we pretty much, let me see, can you see what that looks like? Not really too much, but then watch when we go like this. We just have to take the end of it here. Boom. Copper wire. Stripped. And as you see here, there's a little bit on the end left where the vice grips were holding it. And then all we do to that is just go the other way. And boom, we've got a nice solid piece of copper wire. Okay guys, now you can see here that off camera I stripped a bunch of copper wire. Now we've got a bunch of bare copper. All but one of these pieces are 12 gauge, the other is 14 gauge. And it really does not matter what gauge wire you use. However, the thicker the wire you use, the better yield you're going to get per each wire. And also, the copper wire that is on the anode, that is where all of the oxidation is going to be occurring. So you're turning the copper anode into the copper oxide. So you're going to have to keep replacing it until you reach your desired mass or volume, whichever way you want to look at it, of copper oxide. So that's why I go ahead and I strip a bunch of pieces here. Keep in mind that one of these is going to be the cathode, and that will not get eaten up whatsoever. So that will remain. And I just have all of these here. So I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces. Roughly between 10 inches and a foot. And then I've got this one really long guy up here and I'm going to cut that down because that's just entirely too long. In fact, what I'm probably going to do is this. Okay, so you see how I just bent that wire into a bunch of little, like, I don't know what you want to call it, a zigzag. And so I did that because this is going to be our anode, and it is optimal to have the most surface area or the bigger piece for the anode because it won't go away as fast. And now the way I did this is going to be our reaction vessel. So that you can see I bent it so that it is not touching the bottom. You don't want to have it touching the bottom because then once you start to get your precipitate falling out, the precipitate is going to just end up, or the anode will end up becoming immersed under the precipitate, and it will not react as well. And then kind of tip right there, because that's where our lead is going to attach to. So if you're going to bend it like that, you want to make sure that you bend it to whatever size vessel that you are going to be using. And now we're going to do something similar with the cathode. Okay, so now you see left side here, this is our anode. And over here, this is our cathode. And if you can see it, the cathode does not go all the way down to the bottom, and the cathode can be much smaller. So I actually took one of the pieces that I had that was about a foot long, and I cut it in half. And then we will use the excess of that for another piece of anode. Another thing I'm going to do before I start is, instead of having this with such wide bends, I'm going to take a pair of pliers and crimp these bends right here together a little bit more. And I will show you here just in a second what that's going to look like. All right, so this is our first anode. You can see I kind of compressed everything. And on this last one here, I just kind of folded it down because, you know, and I'm going to actually have to do that to this one here. I'm going to have to bend it over a little bit because you don't want it sticking out of the water, which is why I bent this one down. So for this one here, I'm just going to do this. There we go, easy enough fix. So now you can see that once this goes in, none of it is going to be above the meniscus where the water will be. And so now that we have our electrodes made, the next step then is to make our electrolyte solution. And what I have found works best for the copper oxide is just some water and a little bit of sodium chloride. Now, distilled water is best for this, obviously, because then you don't have any other random ions in there. However, I am just going to use tap water because, for one, it's going to have some chlorine and a little bit of sodium and potassium and calcium in it already, and those are electrolytes in and of themselves. And then I'm just going to give it a little bit of sodium chloride electrolytic booster. And this is not going to form any kind of a complex with our copper oxide. In fact, it's just going to help the electrolysis in its efficiency because of the extra electrolytes in there. And we will get rid of all of those excess sodium, potassium, calcium, etc. ions in the washing step. So let me get this set up as far as the next step goes, and I'll be right back. All right, so you can see here that I have just used clothespins to secure the electrodes to the sides of the bowl. And we want to have the electrodes as far apart as possible. And that is because if we have the anode and the cathode too close together, what will happen is that it will start to oxidize the upper part, or the part of the anode that is in closest proximity to the cathode. And so what will happen is it will like oxidize like here, for example, and then this little J part will just fall off and go down into the solution, and it won't react. So keeping them as far apart as possible ensures that that won't happen. So then the next step is to fill this up to the desired level with some water. And I have a jug here. This is just hard tap water. And I'm going to fill it up as far as I can, because I want to have the electrodes as submerged as possible, because then that allows the entirety of the copper metal to react. Okay, so there, as you see, we are pretty much all the way up to 3/4 of an inch from the top. I've got to reaffix this guy. It kind of popped loose, but I will do that here in the next step, or the step after this. So now we're going to take some of this stuff here, and you don't want to go overboard too crazy with this, because there already are some metal ions in the water to conduct electricity. This is just kind of a booster. So what I do is I just kind of shake in just a little bit like that, and that is plenty. And what I'm going to do is then just stir this up with a glass rod, and I'll be back. Okay, guys, so I stirred all of the sodium chloride into solution. Doesn't take very long. As you know, sodium chloride is very soluble. You can see that the bowl I'm using, the rim is pretty thick, and so it was just a little bit too thick for the clothespins that I was using. So I did away with the clothespins, and I just modified the electrodes a little bit. As you can see, instead of having just a straight 90-degree that came off, I just bent a U right around the rim of the bowl, and then a little tick coming out, and that's where we're going to hook our electric source to. Same thing on this side. And so they're just basically kind of clipped onto the bowl just with gravity and their own weight. And we can see here that we have a little bit of the anode sticking up above water. So I am going to go ahead and bend that so that it goes completely underwater, and then we'll go from there. All right, now you see it's not the prettiest looking design, but I got it all bent so that it is completely submerged. And now the next step is simply just to connect our power leads. So since I am holding my camera, I am going to have to pause this again, and I will hook them up, and I will then show you how to stabilize the current. Okay, so we've got our leads hooked up. We've got our cathode over here on the right, anode over here, just simple alligator clip. If you don't have alligator clips, just wrap a stranded wire around it. That'll work fine. And so I am using this. This is my DC power source. If you don't have one of these, you can use a 9-volt battery. What works better is even a couple 9-volt batteries if you just plug them together in series. You can do the same thing with a couple 6-volt lantern batteries. That works really well. Hook them together in series, and then you get a 12-volt. However, a a benchtop power source such as this is definitely optimal because you can control the amps, which is the current. And that is kind of important because if you have your current too high, it is going to end up destroying your electrodes before they get to fully react. And that's not what we want. So anyhow, so let's go ahead and let's get some juice going. And if you can read what this says here, that says CC, you can't catch it on the camera, and that means that I need to control the current. So we go to our course, current control, and we turn it up just a little bit. And now it's telling me to control the voltage. So we go to our course voltage and we turn it up. And I have found that a really good voltage for this is anywhere between 6 and 10 volts. It just all really depends on, you know, what kind of source you're working with. So I'm going to go up to 10 volts because it is going to just react a lot quicker. And you see, as I increase the voltage, the amperage is going up. So now I'm at 9 point, there we go. I'm going to dial it back just a little bit. And there we go. Now I'm going to take the fine tuning and try to fine tune the voltage up so I can get just at 10. See if we can get it to stabilize. There we go, 10 volts, and we're at 0.3 amps. Okay, so now that we've got that done, let's come over here and look. And what you should see is exactly this. You should see bubbling going on at the cathode, and you do not want it to be bubbling any more vigorously than this. And this is why I say that 10 volts and 0.3 amps is your optimal current voltage ratio. If you have too high of current, you will start to see bubbling coming off on the anode, which you can clearly see there is no bubbling going on, and that is exactly what we want. You don't want bubbling occurring there. You just want the bubbling occurring at the cathode like it is. And so now, guys, it is literally just a waiting game. So you can let this run by itself. It's not going to get all that hot. It's not going to break the glass. It's not going to boil over. What you need to do is just come back periodically and check on the condition of your anode, which is this guy. And if it is completely deteriorated and oxidized in this case, you just swap it out with another piece and you continue that process until you get your desired volume of copper oxide. And like I said, this makes the cleanest copper oxide for any purposes, but especially thermite. For one, it atomizes it, which means that as it is being oxidized, it is literally being broken down into individual copper atoms. So they're very small, the smallest unit of copper that there can be that gets oxidized. And so when you're using for thermite, the finer the particles, the better, because then you have a lot more surface area to react with your aluminum or magnesium fuel that you're using. And so that is really all there is as far as this goes. Oh, I don't know why I just did that. Sorry about that, guys. Anyhow, we're back. So I will come back with an update and show you what this looks like once we start to get some product going on. So the elapsed time has been roughly 10 minutes, and you can already see the formation of copper 2 happening, as is apparent from the blue tinge in the water. You can see still there's our bubbling going on. This is our cathode. Come over to our anode. Now, you will see bubbles forming on the cathode, as you see here, but it is not vigorous bubbling like you have going over here. This is the anode, this is the cathode. I'm sorry, I am very tired and a lot of other stuff is distracting me right now, but anyhow, you should see some bubbles forming on the anode side, and you should see vigorous bubbling on the cathode side. And then just so you can see what's going on here, you can see that our voltage is still stabilized at just over 10 volts, and we're at about 356 milliamps, and that is plenty. And you see every once in a while it jumps, but unless you see these lights going back and forth, that means that you have a stable current. So then, yes, this water is turning a little bit blue because of the copper 2 ions that is reacting with the chlorine in the tap water, and also with the chlorine and the sodium chloride. However, once it reacts further, it's going to convert those chlorides into oxides by a process of electrolytic oxidation. So this is after 2 days now, and I have had to change out the anode. It already ate up one of the anodes, and you can see what's going on here. It's forming some copper hydroxide that floats on the top, and that will just get washed away when we do the washing steps. You can see here on the anode the copper oxide forming, and on the bottom there is a bunch of other copper oxide. This was completely clear solution until I changed out the anode, and it kind of mixed everything up. You see it swirling here now. But when you're doing this at home, you should just be able to see here. You can get a better view on this side. There is all of our product at the bottom with a little bit of mix of the hydroxide and chloride on top there. So just wanted to give you guys an update, show you what it looks like. I'll be back later. Okay, people, I just wanted to show you what this looks like here. So this has been going now, running I should say, roughly a week. I have completely gone through all of my pieces of copper that I had made for the anodes. You can see here around the rim of the bowl, that is all copper chloride. And if you leave that in there long enough with current running through it, it will eventually all oxidize into copper oxide. However, this is already kind of a long process, as I'm sure you can tell. You know, like I said, this has been running for about a week now, and every day I would say I have had to swap out for a different anode at least twice. But that said, though, this makes the best copper oxide that I have found for purposes of thermite and really anything else that you would want to use it for. The reason why I like this is simply because you can just set it up and pretty much walk away from it. Once you get the current stabilized, you only have to come back and check it periodically to swap out your anode. The other thing that's nice about it too is that you do not have to start from some kind of a copper salt like a nitrate or carbonate or something like that. So if all you have is elemental copper, this is a pretty easy route to go about turning it into oxide. So the only thing left to do here is literally to I don't even usually try to decant the water off, because in doing so you will inevitably kick up your oxide layer on the bottom, and you'll end up dumping out a bunch of your product. So what I do is I actually just put this all through a gravity filter. I use a vacuum filter just because it's so much faster and I have access to one, but if you don't, gravity filtration will obviously work just as well. And literally, so then all that needs to be done is you filter it. I wash it a few times with some distilled water, and it's important to use the distilled water for the washing steps because we are trying to rid this of any stray metal ions that would have been in the tap water. And so that effectively does that. And then usually then for the final washing, I will either use alcohol, either isopropanol or ethanol. Methanol will even work. It's just a lot more expensive and kind of harder to come by. Or something like acetone is what I use to wash it for the final washing, just so that it dries a little more quickly. Now, as you can see, I'm still running this here because I've still got some more. Well, this is my last anode here. So once this is done, I will quit running it. But literally, all that needs to be done to this to prepare it for use is to filter it and then just leave it out to dry. Putting it into some type of a desiccator with a drying agent obviously is going to be more efficient and a little bit faster. However, you can just throw this onto a paper plate and put the paper plate on a layer of paper towels and it will dry up pretty quickly. And since we already have copper oxide here, you don't have to worry about it decomposing into anything. So just some food for thought. You don't have to use any kind of high-tech desiccator and or desiccants for this process. So I'm going to continue to let this run until this last anode is chewed up, and then I'm going to filter and dry it. However, I don't see the point in showing you guys the filtering and drying steps here. It's extremely straightforward, and I'm assuming anybody watching this video already knows what a filtration process looks like. So that's it, guys. That is a very easy way to go from elemental copper to copper oxide. And like I said, you can literally set it up, get your current stabilized, and walk away from it. You got to just remember to keep periodically checking that your anode has not completely oxidized away, because then you're just going to be wasting battery or electricity, as the case may be. And I mean AC electricity going into your power supply such as this. So, if you don't want your electric bill to be stupid crazy, then you want to keep an eye on it. But that's literally it. You have now made a very fine powdered copper oxide. Hope you guys enjoyed. See you next time.